This is Surikuri Thanikela, one of the co-founders of Space Education Initiative, and we're going to do today's lesson on brown dwarfs, or failed stars. Let's get into it. So today's question is, can stars become planets? Let's think on that for a little bit. And the answer is yes, stars can become planets, but they must be brown dwarfs. And as you can see, that's an example of a brown dwarf. Now our question is, what exactly is a brown dwarf? I mean, I've never heard about it, right? Okay, so we're going to look at the scale, the mass scale between a star, the brown dwarf, and the Earth. The mass of a regular star is a lot more greater than the mass of a brown dwarf. The mass of the brown dwarf is a lot greater than the mass of an average planet such as the Earth. And this is why some scientists don't consider the brown dwarf to be a planet or a star. The difference between a star and a brown dwarf. So basically, stars have enough mass to make a nuclear fusion with regular hydrogen, while the brown dwarf doesn't have enough mass to make a nuclear fusion with the regular hydrogen. Here's our little demo of nuclear fusion. There we go. Now I was talking about heavy hydrogen and regular hydrogen. So basically, brown dwarfs, they can do nuclear fusion with heavy hydrogen and not regular hydrogen. So what's really the difference between these two types of hydrogens? So basically, hydrogen has three different types of isotopes: protium, deuterium, and tritium. And basically, the difference between heavy hydrogen and regular hydrogen is that heavy hydrogen has a neutron and a proton in its nucleus, while regular hydrogen only has a proton in its nucleus, as you can see in the first two diagrams. Notice how there's a N standing for neutron in the second diagram, while as the first diagram doesn't have it. Here's a little chart demoing what I just said. So basically, in heavy hydrogen, the neutron inside the nucleus makes it easier for brown dwarfs to fuse two atoms of the heavy hydrogen together. And for regular hydrogen, the extra neutron makes the nucleus of the heavy hydrogen heavier than the regular hydrogen. You might be wondering, oh, it's just a small little neutron, but that really does make a difference. One thing I want to address is the scarcity and rarity of the heavy hydrogen causes the brown dwarf to stop producing heat and light energy at an early time in its life. And this is because it doesn't have access to heavy hydrogen as much as regular stars have access to regular hydrogen. So a brown dwarf is stationed in the center of a solar system just like any other star, such as the sun, as we can see in the diagram. So having not many resources of heavy hydrogen, the solar systems with brown dwarfs as the center end up being very dark and cold without light or heat energy radiating from the brown dwarf. And scientists have only found several thousands of brown dwarfs because of its dark appearance over most of its lifespan, which makes it a really hard, aspect to detect through a telescope. So it doesn't mean it's rare, it's just really hard to find. And that's it for today, everyone, on brown dwarfs. I hope you guys enjoyed this video. Please like, subscribe, and share this.